Hello, my name is Carl Cook, and I'd like to give you a brief introduction to NGO 3. The NGO is a classic application of ours that was actually first created back in 1995 for solving the challenge of building predictive models using neural networks. And so the issue was neural networks were good at doing various kinds of regression models where you don't know what the equation is, and you want to have nonlinear models, and but there was the challenge was is that you didn't know what kind of model to use and what kind of structure inside the model and which combinations of inputs. So we created something called the Neurogenetic Optimizer, NGO, which would do that for you automatically. And the NGO has gone through many changes through the years, and this is NGO version 3. It doesn't anymore use neural networks per se because we have found certain limitations, particularly related to extrapolation with neural network models. And being inventors of algorithms, we came up with a new way of extending beyond neural networks to something called mesh models, which is what we use here. And but the concepts are quite similar, although the algorithms are somewhat different. Now, after you install the NGO, one of the first things you need to do, because the NGO requires you to run with administrator privileges, you need to go find the NGO's executable or the shortcut link to it and set it to run as administrator. So in this system's case, we need to find the NGO on this 64-bit system, Windows 8. It's under C, Program Files, x86, Biocomp Systems, NGO 300, and right-click and select Properties. Go to the Compatibility tab and check on Run this program as administrator, and then click OK. Then when you start it, you should see a dialog come up from Windows asking you to elevate the NGO to administrator privileges, and then everything will run fine. This is because of where models are saved as it's building them. And if you build models and it has an error after building models, it's likely because you have not set it to run as administrator. Now, the NGO's user interface at the first showing here is relatively simple. You have a couple of different options for modeling. One is to do regression types of models, and the other is to do self-organizing maps or clustering models. And there's also an assistance tab where you can get access to the help documentation, and there's information in there about each of the controls and each of the windows and how to use the NGO. And so please do feel free to read that over as you see fit. Also, when you first start the NGO, you'll be greeted with a activation dialog, and we will have provided you a user ID to copy and paste into that dialog. If you want to move your license to another computer, you can install the NGO on many computers, but then the license, you can check it into our servers. You need to be connected to the internet, and then go over to the other machine and start up the NGO, and it will say, I need to activate, copy and paste in your user ID, and click OK, and it will go ahead and activate the other machine. So you can move around from computer to computer. So if you're traveling and you want it on your laptop, you can go and deactivate your desktop, activate your laptop. You can do it at your convenience, 24 hours a day, 7 days a week, just by checking in and out your license. Okay, so let's get started. I'm going to click the Models button on the main toolbar, and up will come the Model Builder window. And there's various stages that you go through to construct and validate models, one of which has to do with what data am I going to use? And then how am I going to pre-process that data to create perhaps other variables or clean up the data as you see fit. There's a lead lag for time series data where you can see correlations at time delays and make some adjustments. I won't go into that much. This is an introduction. There's model construction. So this is where you define how to build the models. What are you going to use as candidate inputs? What are you going to estimate, and what kinds of models to build, etc. Once it's done constructing models, then you'll go to the Models tab, and you can then take a look at what we call an ensemble or a committee of models, and you can pick and choose in there which ones you want to use or keep, because it will come up with numerous alternative models. And then finally a validation tab where you can look at the resulting what we call system model and generate reports and looks at charts and graphs and whatnot. And then you can save as, save, or open later that system of models that you created. So on the data tab, there's 3 panes here, 3 sections to this tab. The first one is, what data do I have and where is it? The next one is, what data am I going to bring in and use? And then the third one shows you just basically the data itself to make sure that it actually imported correctly. Now there's some rules on data that you must be aware of. One is that each row, the first column, should have an identifier in it, the first column. That means like if it's time series data, that would be like date time. The second column and third and fourth and onward is the data itself. It does not have to be numeric data. It can be numbers or text. The second rule about data is that the first row in the data file needs to be a field labels, column labels. And so let me go get a data file and load it in and show you. So I'm going to get this data file, which is a comma delimited text file that was created in Excel and exported out as a comma separated value file. You'll notice that you can get text files or Excel. Behind the scenes, the NGO has many more different ways to access data in different formats, but we just exposed text files in Excel for right now. We don't really suggest so much Excel because what you see in the user interface of Excel versus what is in the sheet itself when you go to open it may be different. And you're also involving other technologies behind the scenes where text files much simpler. So I've mapped in this data file, and by default it will go and get all the data out of that data file, and it will show me those field labels at the top of the columns. So I have a date time, input A, input B, input C, and output for demo purposes. It'll show me a grid of I think it's the first 10,000 rows, and so that I can see that it imported correctly. Structurally the data is okay, and I can also, if I desire, take a look at a data chart by clicking on a variable over here and clicking on the chart button. Now, if you want to, the NGO will remember this file and its location, basically forever. If you want to remove it, you just select whichever files you want to remove from this list and click the Remove Data Source button. You can also, if you make various changes, you can force a re-extraction of the data out of the file. And I showed you the chart. And you can also export the data out. And you can put it into various tab delimited, comma delimited, semicolon delimited, and space delimited files, depending on where you're at and how you like it. So we've basically imported 99 rows and 5 columns of data. Now the next tab is pre-processing, and there's again 3 columns to this window as well. One shows me the variables that I have. This list is the available functions that I can apply to those variables, and this becomes the list of functions that have been applied to these variables. There's also a variety of toolbars. I can chart certain variables, so I can select A, B, and C and click the chart button, and it will show me trend plots of that data. I can put that on a this is on a row basis. I can also put it on a time basis, so it makes use of the timestamps that are in there. I can also do a histogram of the first variable. I can do scatter plots of variables. I can reverse the plot order so that if I'm looking at data here and I want to change the plot order, I can do that. I can also click the crosshairs and mouse over and see what the values are. I can turn on and off the legend. I can save this chart to disk or copy it to the clipboard. So you have various ways to inspect your data while the raw data and while you're working on it. Now, if I take a look at some of these variables, and that's always handy to do, I can see that my output variable has these big spikes in here. And if I have some understanding of my data, I might conclude that these are, in fact, outliers. So I can use something by clicking on the output and this first brush button. I can auto filter that, and what it will do is it will do some sort of sophisticated histogram distribution computation and move boundaries in from the outside edges of a histogram to trim off values that are infrequent and extreme. And if I go and take a look at that clipped variable, instead of being down around -2000, I'm down having values around 90 or 100. And I can also look at that and say, well, really I want to clip everything out that's less than 40. Well, I've got this clip applied function over here, and I've got the upper and lower thresholds. I can go in and actually change those. So I can say that I want to clip everything that's outside of -40. So I can just go in and change that value, and then if I look at the chart, I can see that I've clipped everything to -40. You'll also see that there's gaps. Null values are allowed, and one way around that is to go to this button and click pull forward. If it's time series data, you can fill those gaps by using the prior values. Since you don't know what the values are at the null point, you can pull forward the prior values. The next button is to drop null columns. I don't have any null columns, but your data might have columns that actually have nothing in them, and so you want to get rid of those. You can undo the functions that have been applied stepping backwards, or you can undo them all, remove all, and go back to the raw data again. And you can, after you pre-processed, you can click the export, the pre-processed button data, and export it to disk, because maybe it's useful to go put it into a different software package, or send it to somebody that they might find that it's useful. So let's pretend that I've cleaned up my data, and I can see that my pull forward actually filled the gaps in there. Let's skip the lead lag for the moment. Let's go to the model construction. Now I want to build models, alternative models. So I'm going to change this window size a little bit, and I'm going to select these three variables, and this first button says optional input. That means that the model search algorithm can turn on and off these inputs to determine whether or not it wants to use them. The next button, I can say, no, these are mandatory inputs. No matter what, use this input, because I'm going to use that input somewhere downstream in another process, and I require it to be there. Or I can say, ignore this input. Leave date time as a tag. Now, tag just means that it's an identifier column that's not used. This last one is my output that I want to predict, so I use that to click that. And now it's set to be my predicted variable. You'll notice that this Start Modeling button became enabled because now you can create models. You have inputs and outputs. Now we won't go through all the details of the data handling, the model settings, and performance settings. There's a lot of different ways, but of doing data handling, the default works quite well, and for the purpose of the time frame that we have for this video, we'll just use the defaults. But basically what's going to happen is the NGO will take this set of data and break it into multiple subsets, one of which is for modeling, which is regression. So it's actually going to fit that data. And then there's something called optimization. As it fits the data and it's searching for optimal models, this optimization plus the modeling regression accuracy is going to be used to determine which models are better and attempt to create better and better models. The last group that this will be split into is called selection, which says in this swirling mass of alternative models that are getting better and better, which ones do I pull out of there to say these are good models? I'm going to validate them one more time, a third validation. And the ones that model well and optimize well and select well will be put into my list of models that were constructed. And so that's the basic concept. A fourth data set, it can be held back, and that would be 25% of the data will be held back from the entire process for purposes of validation. Or you can set that to 0, oftentimes we do, and then use another data set to validate on, an external data set. This system will construct 100 models, saving the top 10 on that basis. You can have it repeat that process multiple times. And you can build freeform meshes. Those are models that take inputs and have outputs, but the structure inside is completely freeform and can be wired in any way that the NGO deems is useful. The BP mesh is a reduction of the mesh algorithms down to emulate backpropagation neural networks, and those can be standard. That is to say, input is related to output directly, or temporal, which means time-based, which means it can look back across the inputs and compute a trajectory as to what's going to happen on the outputs, or adaptive temporal, which is the most sophisticated backpropagation neural network in the sense that the look-backs over time actually adapt and shift as it's building the models. Then there's also a GR mesh, which is also a reduction of the mesh technologies down to emulate generalized regression models, which actually memorize the data. We won't go into the other aspects at this point, other than you can limit the number of inputs, or you can create models of different diversity, and you can also use multiple cores on your system while modeling. Okay, let's push the go button. Over here we'll see the predicted versus actual for the current model being created, and we'll see that it's building model, whoops, already done, up to it counts off the model numbers as it's going upwards through the 100 that it's building, and it gives you some information about the current model, number of inputs, and what the performance is in terms of accuracy. Now, one of the things that I didn't tell you that I know about the data set is that only variables A and C have anything to do with the output. Input B is immaterial. And so the output is a function of A and C. And so let's go see if it's figured that out. So we'll go to the models list. Now, in the models list, you have a committee of models. These are physical models that were created. They're mathematical mesh models. And this is a system model. The system model is computed by using a model merge algorithm that takes the output of these models and combines them Here it just uses, sums up all the outputs and divides by the number of models. It's just taking the average of the committee to come up with a system model. I can click on the system model or any model, and I can see its predicted versus actual over here on this side, where the red is the estimation coming out of the model, the blue is the actual. And I can see that for the system model, which is the aggregate of all the physical models, that input C is most important, input B, A is most important, input B has very little importance, 0.00992 compared to 0.57. So this is a normalized ranking of each variable's effect on the output, and this way we can see that C and A have an effect on the output and B basically doesn't. And that's a good thing because that's what we expect. I can click around on these different models and see their different charts. I can also right click on this list and pick a metric to look at. Let's say correlation. And I can click on this list and sort. So now I have, let me click twice, now I have the highly correlated models at the top and the ones that have a little lesser correlation at the bottom. I can actually go through and select these three down here that are worse off than the system model, and I can go and delete the selected models. This allows me to prune my committee and say remove the top, or remove the bottom 5 performers or whatever, and kind of bring my committee down to something that's a little higher performing. If I want, I can remove all the models because maybe I want to go back and build some new ones. If I go back to do model construction again, it will add in another 10 into the models list. I'll have 17 at that point, physical models. I can export the system model, selected models, or all models outputs. That's useful. If you have lots of data, clicking on this will cause this chart to take a long time to update. Let's say you have 2 million records. So if you're in here sorting and doing this and that, and you don't want the thing refreshing the chart, maybe it takes a while, then you can toggle this pin so that it only will show the system model and won't be updating the chart. You can also say, well, I want to keep this guy in here, but I want not use him. So I can keep him in there, but I can turn him off. So in use is no. Also, if I select a physical model, let's say this one, if I click on the surface button, I can then do a 3D response surface or 2D response curve. Let's say if input A and input C versus the output, you click this button and it will, let me make it bigger because it's kind of cool to look at. You can then get this 3D response surface. If you left click and drag, you can move this around. And if your boss is coming by, then you can set it to spin so that you look very impressive. So yes, I've come up with this nonlinear model estimating Nernrand's frequency based on proton charge particles or something, whatever is appropriate to your business. And so now you can see how A and C impact the output of the model. And we can stop the spinning because after a while it gets a little... Now if this guy is a little annoying, you can turn him off. All right, so that's kind of cool. And it's useful. You can say, oh, look, it's a nonlinear relationship between age and willingness to buy our insurance policy, or whatever the application is. And you can also reset that if you get kind of lost in reorienting the surface. All right. So that's a quick tour of that. You can change which inputs. This one only uses A and C. Let me see if I see one here that I think they all use all models. Oops, here's one that uses B. So I can go to the A and B versus the output, and you can see for model input B that nothing really changes as B changes, but when A changes, there's a large change. Yeah, so you can see the effect of B, which is just nothing. Good. So now you can go to the validation tab, and you have lots of different kinds of things you can do here. One of which is to again look at the data on the time basis or row basis. You can do histograms of the values of the errors, absolute and raw signed. You can do accuracy histogram. You can do a scatter plot of the predicted versus the actual. That's the red versus the blue. Or the error versus the actual, or the error versus predicted. Or you can do the error versus each input. You can also click on the crosshairs and take a look at different values. And you can toggle the legend on and off. And you can generate a modeling system report. This is a Microsoft Word document. So let me put it into my data folder here and say demo report. And down here you'll see processing report, report complete. And let's see. If I go into my data file, I don't know if this will fit on the screen here. Let me get down here. This will give you a system modeling report that tells you all about the data, the pre-processing, the performance of each model, and the trend charts and scatter plots, and it's quite impressive. You can give it to your colleagues and your boss, or keep it handy for future reference for your good self. And you can save this chart or whatever chart to the disk or to the clipboard. If you have multiple outputs, which is possible, you can select which output that you're looking at. Over here you get various statistics. So I'm going to save this as demo system, and down here it says save successful. Okay, so but I want to make predictions on a new data set. Oh, how do I do that? Well, I just happen to have another data set. Well, it's the same data set in a different text file called to be predicted. And basically it has the same data in it. I'm just showing that it's a different data file. And by selecting that, it actually went and got the data and processed it through, if you didn't notice that. Let me remove that. Are you sure? Yeah. Okay. Now I want to... Now watch down below where it says models loaded and calculations done. Oh, very busy. Done. So it took that data to be predicted, pulled it in off a disk, passed it through the pre-processing, through this algorithm, through each of the models to recalculate all of this and put the results in the validation tabs. That's just as simple as that. You can export your predictions here, system model, selected models, or all models, and you can export your predictions to disk using this new data file. And let's say that you made some changes and you want to do that again. Just select that file and extract the data. Zip, done. Anyway, so this is a brief introduction to the modeling aspect of the NGO 3. Hopefully that gives you enough information to get started. And I appreciate your time, and have a great day.